Good morning, grade 11. Hope you are all doing fine. This is Miss Pamela Teeny giving the physics course. Today we are going to continue chapter 5, section 3, forces in two dimensions. So if you can all please open your books on page 136 so you can follow up with me. In our last session, we talked about the equilibrium force and how we can find it, and we talked about forces in two dimensions on an object that is on an inclined plane. Today we are going to continue. So as a recap, in order to analyze the situation of an object on an inclined plane, first we identify the forces acting on the object, which are the normal force, the gravitational force, and the kinetic friction. The kinetic friction acts parallel to the inclined plane and opposite to the motion. The normal force perpendicular to the plane, and the gravitational force downwards toward the center of Earth. Second, we draw the object's free body diagram as you can see in the figure in front of you. And third, we choose the appropriate coordinate system. So here the most appropriate coordinate system is where the x-axis is parallel to the inclined plane and the y-axis is perpendicular to it. So it's parallel to the normal force. Today we are going to talk about the calculations of these forces. Now, in order to find the magnitudes of the forces acting on the object and to find the object's acceleration, we have to follow the steps that I will demonstrate in the following example. Example: a 45 kilogram box is sliding down on an inclined plane. If the coefficient of kinetic friction between the box and the incline is 0.35 and the plane is inclined at 25 degrees above the horizontal, find the magnitude and the direction of the box's acceleration. So in order to do that, we have several steps that we need to follow. So please concentrate with me so you can understand each step. Like in any other problem, first we write the given. The given here is mass equals 45 kilogram, coefficient of kinetic friction equals 0.35, angle equals 25 degrees, and the unknown is acceleration. As we know, according to Newton's second law of motion, we need to know the net force acting on an object to find its acceleration. In addition, here we have forces in two dimensions, so we need to consider both the x and y components of each force. So because we are not talking about forces only in one dimension, we are talking about forces in two dimensions, so each force or each vector, even the acceleration, have two components, x and y components. One component on the x-axis and the other on the y-axis. So in order to find the acceleration, we need to know the net force, and for each physical quantity or for each vector, we have x and y components. As we already explained, first we identify the forces acting on the system, and in this case, the box is the system. The first force is the gravitational force, and it is acting on the box downward toward the center of Earth. The second force is the normal force, and it acts perpendicular to the incline. The third force is the kinetic friction, acts parallel to the incline and opposite to the object's motion, to the box's motion. In the second step, we draw the object's free body diagram where the box is represented as a dot and the forces are vectors coming out of this dot. The dot is on the inclined plane. The normal force is perpendicular to the plane, gravitational force is towards the center of Earth, and kinetic friction force is parallel to the plane and opposite to the motion. In the third step, we choose the most appropriate coordinate system. Here, the most appropriate coordinate system is where the x-axis is parallel to the inclined plane and the y-axis is perpendicular to it, so it's parallel to the normal force. In the fourth step, we find the magnitude of each force. The gravitational force is equal to mass times acceleration due to gravity, equal to 45 times minus 9.8, equal to negative 441 newtons. The normal force is equal to minus m times g, because it is opposite to gravity, as we all know. So it's equal to minus 45 times minus 9.8, and the answer is positive. Why? Because the normal force is upwards and the gravitational force is downwards. This is why the normal force is positive and the gravitational force is negative, because we consider the downward direction as negative. The kinetic friction force is equal to the coefficient of kinetic friction times the normal force, equal to 0.35 times 441, so it is equal to 154.35 newtons. So this is the amount of force that opposes the motion of the object. In the fifth step, we resolve each force into its x and y components. In order to resolve the force into its x and y components, we need to know the angle between the force, the vector of the force, and the horizontal, which is the x-axis. So for the normal force, the angle is 90 because the normal force is perpendicular to the surface, so it's perpendicular to the x-axis. So as you can see in the solution in front of you, the x component of the normal force is equal to the normal force's magnitude times cosine angle, equal to 441 times cosine 90, equal to 0 newtons, because it doesn't have an x component. All of it is on the y-axis. However, the y component of the normal force is equal to the magnitude of the normal force times sine angle, so it is equal to 441 times sine 90, equal to 441 newtons. Now, for the force of kinetic friction, the force of kinetic friction is parallel to the x-axis and in the opposite direction. So the angle between them is 180 degrees. So the x component of the kinetic friction is equal to the magnitude of the force times cosine 180, equal to negative 154.35 newtons, because it is on the negative side of the x-axis. And the y component is equal to the magnitude of the force times sine 180. It's equal to 0 newtons because all the force is on the x-axis and none of it is on the y-axis. However, for gravitational force, it has both x and y components. The angle, in order to find the angle between the gravitational force and the x-axis, we use geometry. So as we all should know that the summation of the angles of one triangle are equal to 180 degrees. So here we have the first angle is 25 degrees, the second angle is 90 degrees, and we need to find the angle between FG and the x-axis. So this angle is equal to 180, which is the summation of all the angles in the triangle, minus 25 plus 90, which are the two angles that we know in this triangle. So the angle between FG and the x-axis will be 65 degrees. Now we use it to find the x and y components of gravitational force by using the equations that we already studied in the first section of this chapter. So the x component of the gravitational force is 186.37 newtons and the y component is negative. In step number 6, we find the net force in the x and the y directions. So we add all the forces in the x direction and we add all the forces in the y direction, as you can see in the solution in front of you. Fnet in the x direction is equal to normal force in the x direction, kinetic friction in the x direction, and the gravitational force in the x direction, and the answer is 32.02 newtons. However, the net force in the y direction is equal to the y components of all the three forces, the y component of Fn, the y component of kinetic friction, and the y component of the gravitational force. And the answer is 41.32 newtons. In step number 7, we find the acceleration in the x and the y directions using Newton's second law of motion, which states that the net force is equal acceleration times mass. So acceleration is equal net force over mass. So here we find the acceleration in the x and in the y directions. The acceleration in the x direction is Fnet in the x direction over mass, equal 32.02 over 45, which is equal to 0.71 meter per second squared. And the acceleration in the y direction is the net force in the y direction over the mass, which is equal to 41.32 newtons over 45 kilograms, equal to 0.91 meters per second squared. Now in the final step, step number 8, we find the magnitude and the direction of the total acceleration. We also took these equations in section 1 in order to find the magnitude and the direction of a vector. So we use the same equations. To find the magnitude, we do radical x component squared plus y component squared, as you can see in front of you, and the answer here is 1.15 meter per second squared. And to find the direction, we do tangent minus 1 into y component over the x component. Tangent minus 1 is shift tangent on the calculator. So it's tangent minus 1 into 0.91 over 0.71, and the answer is 52.03 degrees. And here we have the final answers, which are the magnitude and the direction of the total acceleration of the box. As a homework, please solve the following problem. A 5 kilogram ball is sliding down an inclined plane. if the coefficient of kinetic friction between the ball and the incline is 0.24 and the plane is inclined at 31 degrees above the horizontal. Find the magnitude and direction of the ball's acceleration. Please, your homeworks must be done and submitted by Thursday, April 2. Thank you and good luck.